Hello there, Mr. Sutton here, bringing you the Algebra 2 11.3 Part 1 homework solutions on geometric sequences. On this problem, they're trying to figure out if the sequence is geometric, and they want the reasoning behind that. So to see if it's a geometric sequence, we just have to see if there's a common ratio when we divide each term by the term before it. So let's just do that. 48 over 96, I could reduce that to 1 over 2. 24 over 48 is also 1 over 2. 12 over 24 is 1 over 2. And 6 over 12 is 1 over 2. Since we get the same ratio each time, that suggests that, yes, this is a geometric sequence because we have a common ratio. To see if this sequence is geometric, let's see if there's a common ratio. So let's divide each term by the term before it. We've got 4 divided by 2, which is 2. 6 divided by 4 is not 2, it's 3 halves. Since we already don't have a common ratio, this is a no, not geometric. For this problem, they want a rule for the nth term of this geometric sequence and then the 7th term specifically. So let's write our general formula out for a sequence nth term. That would be a sub n equals a1 times r to the n minus 1. And we just have to figure out a1 and r. A1 is just this first term, 4. R is going to be the common ratio here. So just take any term and divide it by the one before it. If we do 20 over 4, for example, that's going to give us 5. And same thing for all these other combinations. So writing this all out, we have a sub n equals 4 times the r value 5 to the n minus 1. And now to find a7, we have to plug 7 in for n. And for that, we're probably going to want the calculator. So let's do 4 times 5 to the exponent, parentheses, 7 minus 1. And that's going to come out to 62,500. This problem, we're trying to find the nth term of this geometric sequence. So let's write out our nth term formula, a1 times r to the n minus 1. R in this case, we just have to divide a term by the term before it. So negative 3.9 over 1.3, which comes out to exactly 3, which is kind of nice. So plugging that in with our A1, A1 is just the first term, 1.3. So we've got 1.3 times negative 3 to the n minus 1. And now to find the 7th term, let's just plug 7 in for this n here. So going to Desmos to calculate that, let's do 1.3 times negative 3 in a parentheses. Raise that to, and I need a parentheses for my exponent, 7 minus 1, and that comes out to 947.7. For this problem, we want the nth term of this geometric sequence. So let me write out my formula. a1 times r to the n minus 1, that's my nth term formula for geometric sequence. And for the r value, you can take any term and divide it by the term before it. Usually I would take the first two terms, but 75 over 375, that looks like a pain to divide and reduce. So I'm going to go the easy road and do 3 over 15 instead. I could have picked any of these, but this is the path of least resistance. So that reduces easily to 1 over 5. So plugging that in with my A1, A1 is the 375, so we can't avoid that forever. And we have that times the 1/5 to the n minus 1 power. Next up, to get the 7th term, let's plug 7 in for n. And let me go to Desmos to figure this out. So just clear out what's already in there. We'll do 375, parentheses, 1 divided by 5. Close that parentheses. Exponent, parentheses, 7 minus 1, or just 6. And that's 0.024, or as a fraction, you could call that 3 over 125. Either is acceptable. For this problem, they want a rule for the nth term of this geometric sequence and also the 7th term. They actually gave us the first 5, but we got to keep going. So this is a geometric sequence. Let me write out my formula for nth term of that. That's a1 times r to the n minus 1. So for the r value, we're just going to see what we're multiplying by each time to get each new y value. So if I do, there's a lot of ways you could do this. Probably the easiest would just be to do, well, literally any of these, but I'm going to do 1 divided by 0.5. That comes out to 2. It might have been even easier just to do 2 divided by 1, but hey, we're here now. So the A1 is just the output for your first n value. So 1 comma 0.5, that means our A1 is going to be this 0.5 right here. So we have 0.5 times 2 to the n minus 1. That's our general formula. To get the seventh term, we just have to plug 7 in for n. And we could use the calculator on this, but we probably don't need to. I mean, this is just 2 to the sixths, which is 64, and half of that is 32. For the next couple problems, they want a rule for the nth term of a geometric sequence in which they are giving us some random term and the r value. All right, so in order to do this, I'm going to need to get the A1. That's part of my formula here. Let's just write out that formula. A1 times r to the n minus 1. We've already got the r. We need the A1. So I'm going to plug in all the information they've given me to solve for A1. Then I'll plug that back in, and that'll give me my final formula. So for the a sub n, I'm going to use the value of a sub 4, which is this negative 500. A1 we don't know yet. R is 5. And then n is just the index of the term I used for a sub n. So that's just the 4. So 4 minus 1. 4 minus 1 is 3. 5 to the third is 125. So we have 125 A1. And then dividing by 125, I believe that's going to be negative 4. And now I can plug that in with the A1, or with the R rather, that they gave me in the beginning. So this is going to be negative 4 times 5 to the n minus 1. To get the nth term formula for this problem, let's actually write out the general formula first. So we have A1 times r to the n minus 1. Now we've got the r value already. We still need to find the A1 in order to complete the formula. They gave us A5, so what we're going to do is plug in the value of A5 with the index 5 and the r value, and that'll get rid of just about everything except this A1, which we can then solve for. So for a sub n, I'm going to plug in the 3, that's the a sub 5 value. A1 we're looking for, negative 1/3 is the r value. And then for the n up here, that's just the 5, the index that goes with this 3 that we plugged in. So 5 minus 1 up there. 5 minus 1 is 4. Negative 1/3 to the 4th power, that would be a positive because it's an even exponent. Positive 1 over 3 to the 4th, so 1 over 81. To get A1, I have to multiply both sides by 81. So 3 times 81 is 243. So that's my A1. Plugging that back in, I can now write a sub n equals 243 times the r value of negative 1/3 raised to the n minus 1.